We're going to talk about properties of parallelograms in section 6.2. Now, as you already know, a quadrilateral is a polygon with four sides. However, some quadrilaterals have special properties. These special quadrilaterals are given their own names. A quadrilateral with two parallel sides is a parallelogram, something you also know, so I would not expect you to write that vocab word down. To write the name of a parallelogram, you're going to use the symbol, and it looks like this. It looks like a parallelogram. So you could name parallelogram ABCD by using that symbol followed by ABCD. Now the actual first problem we're going to do is we're going to prove our theorem. So the theorem we're going to prove is 621, which you don't need to know that number. But here's our given. We are given that this is a parallelogram. JK.L.M. is a parallelogram. We want to prove that JK is congruent to LM and KL, segment KL, is congruent to segment MJ. Now we know already that a parallelogram has opposite sides that are parallel. So our first statement would be to write the given. Now, if we write the given, the next step would be to say that segment JK is parallel to segment LM and that KL, segment KL, is parallel to segment MJ. And the reason is the definition of a parallelogram. So now, angle 1 is congruent to angle 2. Once again, we have parallel lines. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4 because of the alternate interior angles theorem. Then we can say that segment JL is congruent to itself because of the reflexive property. And then by angle side angle, these two triangles are congruent. And then we can say, using CPCTC, that segment JK is congruent to segment LM. Now remember this, and I know you know this, but it's important to understand that a quadrilateral with two parallel sides is a parallelogram. So the definition of a parallelogram would state that opposite sides are parallel. So that's what you would use the definition of a parallelogram for. However, from that, you have four properties that you're going to have knowing that something is a parallelogram. Now make sure you do also understand that by definition of a parallelogram, it says that a parallelogram is a quadrilateral with two pairs of parallel sides. That's the only way you can say definition of a parallelogram as your reasoning. So the first property we're going to talk about is this. It says that if you have a quadrilateral and it's a parallelogram, then opposite sides are congruent. You are not going to say as your reasoning definition of parallelogram. You are going to say opposite sides of a parallelogram are congruent. Because remember, the definition of a parallelogram says that you have two pairs of parallel sides. The property states that opposite sides are congruent of a parallelogram. So that would be your reasoning. Opposite sides of a parallelogram are congruent. You could write that out. You could say put it in an if-then statement. It's up to you. But we know that opposite sides would be congruent. Now from there, we have more properties. And you would just actually write them out as your reasoning or write them as in parentheses here. You cannot say definition of a parallelogram. You would say opposite angles of a parallelogram are congruent. You would say if something is a parallelogram. And notice that all of these in the hypothesis say that it's a parallelogram, which means that opposite sides are parallel. So because we have opposite sides parallel, we can say parallelograms have opposite angles are congruent. Parallelograms have consecutive supplementary angles. So that means, for example, angle A and angle B add up to 180. The measure of angle B plus the measure of angle C add up to 180. The sum of the measures of C and D add up to 180, and the same thing is true for the measures of angle A and D. Lastly, we know that diagonals of a parallelogram bisect each other. Diagonals of a parallelogram bisect each other. So in example number 1, we want to find the measures and lengths of each of these pieces. The diagram shows that the parallelogram-shaped linkage that joins the frame of a race car to one wheel of the car. This is a parallelogram, PQRS. Make note, it's a parallelogram. The only thing we know is that opposite sides are parallel. From there, we use our properties. So we know PS, for example, we want to find PS. I'm going to redraw this. So I've redrawn it and labeled the sides. So I want to find PS. Well, because I know opposite sides of a parallelogram are congruent, the length of PS will also be 48 centimeters. The measure of angle PQR, because I know that consecutive angles are supplementary, I know that 73 plus the measure of angle PQR would add up to 180. So 180 minus 73, the measure of angle PQR would be 107 degrees. And lastly, PT. Because I know in the parallelogram, diagonals bisect each other, the length of PT would also be 30 centimeters. In example 2, I am given that ABCD is a parallelogram. Find the measures of the length of AD and the measure of angle B. In A, I want to find AD, which is 7x. Well, I could say 7x equals 5x plus 19, since opposite sides are congruent of a parallelogram. If I solve this, I'm going to get x equals 9.5. I plug that back in to 7x, and 7 times 9.5 would give me the length of AD as 66.5. The measure of angle B. Well, I know the measure of angle B and the measure of angle A. Both of those angles are supplementary. They are consecutive, so they're supplementary. So I add them together, which equals 180. That gives me 16y plus 4 equals 180. I subtract 4, divide by 16, I get y equals 11. If I plug that back in, 11 times 6 is 66, plus 5, the measure of angle B would be equal to 71 degrees. In example 3, we are given 3 vertices of parallelogram ABCD. We're given A, B, and D, so we want to find the coordinates of vertex C. The first thing you would do is to graph all 3 points. So after I've graphed all 3 points, you have to use the properties of parallelograms, or the theorems, to figure out what your 4th point is going to be. Well, because we know it's a parallelogram, we know opposite sides are congruent, but we also know opposite sides are parallel, which means they would have to have the same slope. So I could either go from B to A, or from A to B. I could also go from A to D. So I'm just going to count what the slope is of AD. Well, the slope is going to be up 1 over 4, so AD is 1/4. That means BC would also have to be 1/4. So then C, since it has the same slope, would be the point of 2, 4. So once again, if you are given 3 points of a parallelogram, use the slope to find the 4th remaining point. So in example number 4, we're going to actually write a 2-column proof. Now we're going to be given 2 parallelograms, and we have to prove angle G is congruent to angle L. So here's what we know. We have 2 parallelograms. We know H and M are collinear. So the reason is because you know that HJ is not like a segment and JM is a segment, but HM is not on the same segment. So we know they're collinear, so all H and M lie on the same line. N and K are also collinear. So we'd start by writing our given. Now, what do you think we're going to have to do here in order to prove angle G is congruent to angle L? We'd probably have to go straight across, and since we know opposite angles are congruent, we can work our way across to angle L. So example, or number 2. Number 2, we're going to write that angle HJN is congruent to angle G. We also know that angle MJK is congruent to angle L, for the same reason. And the reason would be that opposite angles of a parallelogram are congruent. So I know that these two angles are congruent, and I know that these two angles are congruent. Well, now I can use vertical angles to say that angle HJN is congruent to angle MJK. And the reason is because vertical angles are congruent. And lastly, what can I say? I can say that angle G is congruent to angle L. Why? What's that property? Angle G is congruent to angle HJN. Angle HJN is congruent to angle KJ.M. And angle KJ.M is congruent to angle L. So I can say that angle G is congruent to angle L because transitive property of congruency.